Hello everyone, welcome to Learn Ladder Logic. Today we'll start with exercise 1.1. Question number 1. Express each number as a product of its prime factors. So, first subdivision 140. We'll do the prime factorization of 140. 140 is an even number, divisible by 2, we get 70. 70 is again an even number, divisible by 2, we get 35. 35 is a product of 5 and 7. So we'll write 5, 7. 7 is a prime number, 7, 1. So 140 is equal to 2 square into 5 into 7. Okay. So next number we have 156. 156 is a prime number. So divisible by 2, we get 78. 78 is again a prime number, divisible by 2. When we divide, we get 39. 39 is not a prime number. When we add the digits of the number 3 plus 9, we get 12. 12 is divisible by 3. So we'll divide it by 3. 1, 3, 13. 13 is a prime number. Just write it. Okay. So we'll write 156 is equal to 2 square into 3 into 13. Okay, fine. Next number, 3825. 3825. Here you see the unit place number is 5. So this number is divisible by 5. So when we divide it by 5, we get 765. Okay. So when we divide 765 by 5, we get 153. Okay. We get 153. Now 153, when we add the digits of 153, it is 6. 6 plus 3, 9. 9 is divisible by 3. So when we divide this number by 3, we get 51. 51 is again divisible by 3. So when we divide it by 3, we get 17. 17 is a prime number. So we are just writing it. Okay. So 3825. 3825 is equal to product of 3 square into 5 square into 17. Here, when you write it that the composite number is equal to the product of prime number, it should be in an ascending order. But while doing the prime factorization, it doesn't matter whether you're doing in ascending order or not. Okay. Next, fourth subdivision, 5005. 5005. This number is divisible by 5. So when I divide it, I get 1001. When I divide this number, it is not divisible by 2, 3, 4, 5. So let's check it is divisible by 7. When I apply the divisibility test, yes, this number is divisible by 7. So I'll get 143. 143 is divisible by 11. 13. 13 is a prime number. 1. So 5005, I can write it as 5 into 7 into 11 into 13. See, this learning divisibility test is very important and you can learn from my channel and be updated with Math Mantra every week. Next, 7429. The prime factorization of this number is divisible by 17. I'll get 4, 3, 7. 437 is is a product of 19 and 23. I'm just writing it here. 23 and 1. Okay. So I'll write 7429 is equal to 17 into 19 into 23. Okay. Done. Let's go to the next question. Question number 2. Number 2. Find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to the product of two numbers. So let's begin. Let's find the prime factorization of 26 and 91 first, and then do the LCM and HCF of these numbers. So the prime factorization of 26 divisible by 2, 13. 13 is a prime number, 1. So I'll write it inside. 26 is equal to 2 into 13. Now, next prime factorization of 91. 91 is a product of 7 and 13. So I'm writing 7, 13, 13 and 1. 91 is equal to 7 into 13. Okay. So what I normally do is that I write the remaining numbers which are not there. In 26, you can see there's no 7, right? So I'll write 7 here. And in 91, you can see there's no 2. I'll write 2 here. But as these numbers were not available, I'll write to the power 0. Okay? You have 13 in both the numbers, so I don't have to multiply 13. I'm just writing all the varieties of numbers in this. In 26, we have 2 to the power 1, 13 to the power 1. In 91, we have 7 to the power 1 and 13 to the power 1. Okay, I hope you understood that I have written all the varieties of numbers, but with giving them a proper power. Now, LCM. LCM is writing all possibilities of numbers, but writing the highest power that number has. Okay. So here, highest power. In these two numbers, first I'll write all varieties of numbers, 7, 13. And what are the highest power? 1, 1, 1. So when I multiply, these two numbers are equal to 91. 91 into 2, I'll get 182. Okay, fine. Next, HCF. HCF, I'll write all the powers, all the numbers, all the varieties of numbers which I have. But I will write the lowest degree that number has, the lowest power that numbers have. 2 into 7 into 13. What is the lowest power of 2? 0, right? The lowest power of 7? 0. The lowest power of 1? 13? 1. So when I multiply, I'll get 13. Here, remember, any number e to the power 0, any number whose power is 0 will value to 1. Okay, simple. So let's do the product of the numbers and the product of the LCM and HCF. Here, LCM I got as 182 and HCF I got 13. So let's do the product of these two numbers first. 6, 24, 3, 5, 0, 2, 8, 1. 6, 6, 3, 2. 2366. Now let's do the product of the numbers given to us. The numbers we had 26 and 91. Okay, so let's do the product of these numbers. 1620. 9 into 6 is 54. 5. 9 twos are 18. 19, 20, 21, 22, 23. And when we add it, 6, 6, 3, 2. Here you can see 2366. So we'll just write it hence. Okay. Product of numbers is equal to LCM into HCF. So we'll just write it, product of numbers. What were the numbers we had? 26 into 91 is equal to, what was the LCM? LCM was 182 and HCF was 13. Okay, which is equal to 2366 is equal to 2366. Okay, I hope you understood. Let's go to the second subdivision of this question, where we have number 510 and 92. So 510, the prime factorization of 510. 510 is a even number divisible by 2. I'll get 255. Okay, this number is not divisible by 2. I'll check whether it is divisible by 3. Adding the digits, 5 plus 5, 10. 10 plus 2, 12. 12 is divisible by 3. So divisible by 3. When I divide it, I get 85. 85 is divisible by 3. 13, no. Divisible by 5 because the unit place number is 5. So when I divide it by 5, I get 1, 7. 17. 17 is a prime number. 17, 1. Okay. So I'll write 510 is equal to 2 into 3 into 5 into 17. Simple. Next, I'll do the LCM prime factorization of 92. 92, the even number, 2, 46. 46 is again even number, 2, 23. 23 is a prime number, 23, 1. So I'll write 92 is equal to 2 square into 23. Okay. Now what I told, we'll compare the two numbers and whichever number is missing, we'll give the power to them. Power 0 to them. Okay. First, before I go, I'll just write power 1 for everything. Okay. I've written power 1. Now I'll write whichever number is missing. Now in 92, you don't have 3. So 3 to the power 0. You don't have 5. 5 to the power 0. You don't have 17. 17 to the power 0. And in 510, you have 2. So I'll not write 2. We don't have 23. So I'll write 22. 3 to the power 0. Fine. Now I'll do the LCM. LCM, writing all varieties of numbers with their highest power. So highest power. So we'll write 2, 3, 5, 17, 23. The highest power these numbers have. 2, 2 to the power 2. 2 is the highest power in 2. 3 is 1, 5 is 1, 17 is 1, 23 is 1. So when I multiply all these numbers, okay, so 2 into 2, 4. 4 into 2 is, 4 into 3. 3 is 12. 12 into 5. I'll get 60. Leaving the 0. 6 into 17. I'll get 102. So this all in total will be 102 and the 0. Okay. Into 23. So I'll multiply it. 1020 into 23. Leaving the 0 aside. 3 twos are 6. 3 zeros are 0. 3 ones are 3. Double 0 in the bottom. 2 twos are 4. 0, 2. And when I add it, 6, 0, 6, 4, 3, 2. Okay. So what I got? I got 23460. Fine. So I'll just write it here. This is not divided by, okay. 23460. Fine. Now I'll do the HCF. HCF, I told we'll write the all the numbers but with the lowest power that number have. Okay. So 2 to the power 2 into 3 into 5 into 17 into 23. What is the lowest power? 2 has 1, 3 has 0, 5 has 0, 17 has 0 and 23 has 0. So HCF is equal to 2. Fine. I hope you understood. Okay, next let's go and solve the product of HCF and LCM and the product of these two numbers. LCM we got 23460 and HCF we got as 2. So when we do the product of these two numbers, we'll get 4, 6, 1, 0, 12, 1, 8, 9. Okay. 46920 and the product of the numbers 510 and 92, leaving the 0 in the bottom. 2 ones are 2, 2 fives are 10, 9 ones are 9, 9 fives 45, 2, 9, 6, 4. Yes, we got the same numbers. So the product of number is equal to HCF into LCM, where the product of two numbers were 510 into 92 is equal to, the HCF we got was 2 and LCM was 23460. And when we multiply, we got 46920 is equal to 46920. Fine. I hope you understood. Now let's go to the third subdivision. Okay, I'll be doing this fast. And I want you all not to do this with me. Do it separately, then check the answer with me so that you understand the concept very well. Okay, the prime factorization of 336, even number, divisible by 2, 168. Again an even number, divisible by 2, 84, even number 2, 42, even number 2, 21, 3, 7, 7. So I'll write 336 is equal to 2 to the power 1, 2, 3, 4. 2 to the power 4 into 3 into 7. Okay, now I'll do the prime factorization of 54. 2 divided by 2, I'll get 27. 27 is 3 into 9. So I'll write 3 cube in the sense 9, 3, 3, 3, 1. So I'll write 54 is equal to 2 into 3 cube. Okay. So here we have 2 in both the numbers. We have 3 in both the numbers. We have 7 only in 336. We don't have 7 in 54. So I'll be writing into 7 but to the power 0. Here 7 to the power 1, 3 to the power 1, 2 to the power 1. Okay. Now we'll do the LCM. LCM writing all varieties of numbers with the highest power. 2 into 3 into 7. Highest power is 4 in 3, 3 to the power 3 and 1. So when I multiply it, here we'll get 2 to the power 4. What is 2 to the power 4? 16. 16. 16 into 7. 16 into 7 we get 112. 112 into 27. 112 into 27. Okay. I'll just do it here. 112, 27. 14, 7 so 7, 8, 7, 0, 4, 2, 2, 4, 12, 9, 10, 1, 3, 1. So what I got? The LCM as 3024. Okay, so I got it as 3024. Next, the HCF, writing all possibility of numbers with the lowest power. 7, the lowest power is 0. For 3, it is 1. And for 2, it is 1. So we got 2 into 3, 6. Okay, so we got LCM as 3024 and HCF as 6. So when we multiply both these numbers, we'll get 6 into 4, 24. 6 into 2, 12, 13, 14. 6 zeros, 0, 1, 6, 3, 18, 9, 18. So we got 18144. And the two numbers available, the given numbers were 336 into 54. 24, 12, 13, 14, 12, 13. 0, 5, 6, 3, 0, 5 into 3, 15, 16, 17, 5 into 3, 15, 16. 4, 4, 1. Okay, then I'll get carry forward 8 and 1. Fine. Now let's do both the numbers we got similar. So we'll just write the conclusion. Conclusion product of numbers is equal to LCM into HCF, where product of the numbers were 336 into 54 is equal to LCM. What we got is as 3224 into 6. We got the answers 18144, 18144. Okay, I hope you understood. Now let's go to the third question. Was it easy? Any doubts, please pin it in the comment. I'll be checking it and helping you solve in the next video. Okay, third question. Find the LCM and HCF of the following integers by applying the prime factorization method. We have learned this. We'll do it quickly. LCM and HCF. First number, we have it as 12. So the prime factorization of 12. Actually, these numbers are easy. I'll just write it here. 12 is equal to 2 into 3, 2 to the power 2. Okay. 4 into 3. Okay. So now 15. 15 is equal to 3 into 5. Power 1, power 1, power 1. 21. 21 is equal to 3 into 7. 3 into the power 1 into 7 to the power 1. Now, what are the remaining numbers? Like, we'll check what numbers are not there. In first question, we have 2. In second and third, we don't have 2. So I'll write 2 to the power 0 in both the places. Okay. In first one, we have 3. Second one, we have 3. And third one also, we have 3. So no issues. In second one, we have 5. But in first and third, we don't have 5. So 5 to the power 0 into 5 to the power 0. 7 is there only in the third one. Just writing 7 to power 0 in first one and in second one. Okay, easy. So now let's do the LCM and HCF of these questions. So here LCM, writing the all possibilities of numbers but with the lowest power. No, sorry, the highest power. So 2 into 3 into 5 into 7. What are the highest power available to them? For 2 we have 2 to the power 2. For 3 we have 1. For 5 we have 1. And for 7 also we have 1. 2 to the power 2 into 3 is 12. 12 into 5, 60. 60 into 7. 60 into 7 we get 420. So the LCM we got is 420. Okay. Now we'll do the HCF. HCF is equal to all the possibilities of numbers but with their lowest power. So 2 into 3 into 5 into 7. I know I have written the lowest power for 2, 5 and 7 as 0. And 3, there was only one common in everything. So the answer we got it as 3. Okay, fine. Let's go to the second subdivision. 17, 23, 29. Here, these numbers are all prime numbers. So we'll write 17 is equal to 17 into 1. 23 is equal to 23 into 1. 29 is equal to 29 into 1. Which all numbers are not given, please write it in the other two. Now 17 I have only in first place. I'll write it here. 17 to the power 0. 17 to the power 0. 23 I don't have it in the first and the third. So I'm writing 23 to the power 0. 29 I don't have it in first and second. So I'm writing 29 to the power 0. Okay. Now we'll write the LCM. LCM is the highest power all these varieties of number have. So the highest power is 17 to the power 1, 23 to the power 1 and 29 to the power 1. So let's multiply and find the answer. 17 into 23. So I'll write it, do it here. 17, 23, 21, 3, 6, 3, 4, 5, 0, 2, 14, 1, 2 ones are 2, 3. I got 391. Okay. 391. So these two numbers is 391 into 29. So I'll be doing 391 into 29. 981. 9 into 3 is 27, 20, 29, 30, 31, 32, 33, 34, 35. Okay. Next. 0, 2, 18, 6, 7. When I add, I'll get 9, 3, 13, 1, 11. Okay. So when I add, I'll get 1, 1, 3, 3, 9. So the LCM is 11,339. Okay. Now HCF. HCF, the lowest power, all the numbers. 17 into 23 into 29. What is the lowest power? 0, 0, 0. And any number to the power 0 is equal to 1. So the HCF is 1. Simple. Understood? Now let's go and do the third subdivision. Okay. Third subdivision is again easy. 8. 8 is 2 to the power 3. So I'm writing directly 2 to the power 3. 9 is 3 to the power 2. And 25 is 5 to the power 2. Now which all numbers are missing? Just we are writing it here. In first number we have 2. In second we don't have 2. So into 2 to the power 0. 2 to the power 0. In second one we have 3. But we don't have it in first number and the third number. Okay. And 5 we have it only in third number. We don't have it in first number. So 5 to the power 0. And second number 5 to the power 0. Simple. Now let's do the LCM. LCM is equal to, writing all the common number with the highest power. 2 into 3 into 5. What are the highest power of 2? So we'll just check. 2 to the power 3. And of 3, 2 to the power 2 and 5 also 5 to the power 2. So when we multiply all these numbers, 8 into 9 into 25. Okay, so 8 into 25, I know it as 200 because 4 into 25 is 100. So 8 into 25 is 200. So 200 into 9, 1800. Simple. Now HCF. HCF, writing all the numbers with the common or the lowest power. So 2 to the power 0 was the lowest, 3 to the power 0 was the lowest, 5 to the power 0 was the lowest, and any number to the power 0 is 1. Simple, because we get 1 into 1 into 1. Yes? Understood? Next, we'll go to the next question. Fourth question. Given that HCF of 306 and 657 is equal to 9, find the LCM of these two numbers. So we know, first we'll write given. Okay, so whatever is given to us. Given is HCF of 306 comma 657 is equal to 9. Now we know, what do we know? That the LCM into HCF is equal to the product of two numbers. Okay, so here we have LCM. We don't know the value of LCM, so I'll just write, let us assume LCM is equal to X. So X into 9 is equal to product of the numbers. What were the product numbers? 306 into 657. Okay, so let's do the product of these numbers here. 306 into 657. Okay, so we'll get 201042. When we multiply these numbers, please have a check whether this number is correct or not. X into 9 is 201042, where X is equal to, we'll divide this number by 9. So we'll get 2, 2, 3, 3, 8. So X is equal to the LCM. LCM is equal to 22,338. Okay, simple. Any doubts, please comment it in the comment section so that I can solve it for you guys. Next question. Check whether 6 to the power n can end with the digit 0 for any natural number n. What do you think? Can any number to 6 to the power 0, 6 to the power n can end with a digit 0? When we see the 6 table, or like the 6 into power 6 to power 2 is 36. 36 to the 36 into 6 is 216. 216 into 6 is 1296. Here you see all the numbers ending with 6. So this is not possible. So let's see how to explain this, like how to write it in the exam so you get full marks in it. Okay, so like if any number, like right, if any number that ends with 0, it should be a product of 2 and 3, 2 and 5, correct, and should be divisible by 5 minimum, like should be divisible by 2 and 5, both the numbers. So I'll write if any number ends with 0, then it must be divisible by 2 and 5. But when we do the prime factorization of 6 to the power n, we get 2 into 3 to the power n. Correct? But we know there is no phi in this. Okay, so we'll write in this prime factorization, there doesn't exist prime number 5. Correct? So hence it is clear. Hence it is clear for any natural number n, n, 6 to the power n is not 6 to the power n is not divisible by 5. Thus it cannot end with digit 0. Okay, we'll go to the next question. Okay, sixth question. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. Okay, so what are composite numbers? We have learned composite numbers are those numbers which have factors other than 1 and itself. Okay, so we'll just write the definition here first. Composite numbers are those who have factors other than 1 and itself. Okay, so in the first subdivision of the question, we got 7 into 11 into 13 plus 13, where if we take 13 as a common number outside, 13, so we'll get 7 into 11 plus 1. Correct? So now 7 into 11 is 77. 13 into 77 plus 1. Here you can see you have 13 as the common factor outside. So this number is a composite number. Okay. Now next, second subdivision of this part. 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Here if I take 5 as a common number outside, it would be 7 into 6 into 4 into 3 into 2 into 1 plus 1. When I multiply 7 into 6, 7 into 6 is 42. 42 into 4 is 168. 168 into 6. 168 into 6. 3 into 2 is 6. So I have just written it here. I'll get 8001. Okay. So I'll get 5 into 1008 plus 1. Here you can see you have 5 as a common number outside. So this is again a composite number, because we told any number which has factors other than 1 and the number itself, you have factor 5. So this is a composite number. So we'll write hence both of the numbers given are composite number. Okay, simple. Now let's go to the 7th question, the last question of this exercise. There is a circular path around a sports field. Sonia takes 18 minutes to dive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Here you can see the keyword as again. Okay, whenever you have such words, here once you have keywords as again, when you're meeting again, or these words like again, or the taking minimum time to meet again, or they are together, they're coming together, these are the keywords for LCM. So this gives us a hint that we have to do LCM. Okay, so let's solve this question. First we'll write given to us. So what is given in the question for us? That who time taken by Sonia. Okay, around the park is 18 minutes. Time taken by Ravi, how many minutes? 12 minutes. Okay, fine. Now we'll write the main answer. Okay, since both are moving in same direction at same time, the time they will meet will be found by LCM of 18 and 12. Okay, so now let's do the LCM of these two numbers. I know 18 is equal to 2 into 3 to the power 2, that is 9. and 12 is equal to 2 to the power 2 into 3, that is 4 into 3. So we have, like, there is no need of writing those numbers again because we have all the numbers given there. It is 2 to the power 1 into 3 to the power 2 for 18 and 2 to the power 2 into 3 to the power 1 for 12. So when we'll find the LCM, LCM is writing the all the numbers in their, all the numbers with their highest power that number have. So 2 into 3. What is the highest power of 2? 2 to the power 2. And highest power of 3? 3 to the power 2. So it is 4 into 9. 4 into 9 is 36. So we'll write the conclusion. Hence, they will meet again. They'll meet again after 36 minutes. Okay, understood? Any doubts? Please pin it down in the comment section. And I'm ending this exercise. Thank you so much. Please like, share, and subscribe.